Thanks. My name is Stefan Wrobel. It's my pleasure to present ML2R, or actually what will be called the Lamar Institute for Machine Learning and Artificial Intelligence. I'm also happy I can't see because of the light. Katharina Morik, who already presented this morning, is also here. We don't really see my slides right now. Is there something I need to do?
To the right? Yeah, here it is.
I see it, but you don't. Oh, there we go. All right, because that's, of course, an important slide, as you can see. Those are the beautiful locations where we're at. We are in the city of Dortmund and the city of Bonn and St. Augustin in the western part of Germany. This is, of course, a montage of two different cities, so we're like 100 kilometers apart. We have two locations, and we will be called the Lamar Institute. Why is that so? We've been... This is to design here. Okay. We started our existence some 4 years ago as a relatively small project, ML2R, funded as part of the excellent competition in Germany. And we've had a very, very dynamic development. And to mark that development, when we were institutionalized now in 2022, we're calling ourselves the Lamar Institute for Machine Learning and Artificial Intelligence. So July 1st, we'll start our official existence as the Lamar Institute. You can see our development at the bottom there with this little timeline. I'm not going to explain all the details here of the things we've been doing. Just the important thing for you to know is that we've really, really been growing very, very strongly. We started with 4 PIs involved, and now there's more than 25 of us, and more are joining every day. We have 4 parent institutions, or 4 parent institutes. That's Technical University of Dortmund, as you see on the right here. There is 2 Fraunhofer Institute, Fraunhofer IAIS and Fraunhofer IML, and there is University of Bonn that make up the up-and-coming Lamar Institute for Machine Learning and Artificial Intelligence. So what is our mission? Primarily, of course, we're an excellence institute in machine learning and AI. So we have a core research agenda that all the PIs that are involved in the Lamar Institute have committed to. And that core research mission is what we call triangular AI. And why is it called triangular AI? Because we believe that's 3 elements that need to be in any self-respecting AI system these days. Why is that so? We can clearly see, and lots of the presentations here have highlighted that current AI systems hit boundaries. They hit risk. On the one hand, we have amazing successes. There is things we never imagined we would be able to do based on data-driven machine learning with very large, very deep models. At the same time, it is clear that there is so much knowledge in the world that we can and should not ignore that kind of knowledge. So we're all working on things like transfer learning, on memory-oriented learning, on remembering things. So the second element that we're bringing into machine learning and AI next to data is knowledge. But we also believe that data and knowledge alone are not enough. That is a too simplistic view of the world, because it somehow seems that we do not interact with the world, that we're not embodied in the world, that we do not have a location and physical or human context. And that's why the third element of triangular AI in all of our research is that humans and the context of the system must be taken into account. We believe that this, and I think the increased predictive power, speed, and generalization have already been proven, will also lead to higher flexibility, efficiency, and reuse, and ultimately also higher robustness. So that is triangular AI. We're just starting that journey. If you want to know more about it, come talk to us. We believe that this will be one of the decisive factors in the next 10 or 20 years of artificial intelligence research. How have we been organizing our research? We have been organizing that research into 5 what we call core research areas. And you can see what they are in the names below down here. You see all the PIs that are involved here in these 5 areas. And at the center of the areas is hybrid machine learning. Obviously, this is the classic. We've been doing that for a number of years. We have a large survey paper out on hybrid informed machine learning. Perhaps many of you have noticed that. So that is the idea of using data and knowledge in ML algorithms. So very, very central. But I also said that the context is very important here, and the context basically plays a role in several of the other research areas. So let's start at the left here. Resource-aware machine learning. we are doing research on different architectures for machine learning. We have, of course, very, very large computing facilities where we use the standard computing GPU clusters, but we also have our own simulated annealing hardware, digital annealer. Perhaps some of you know the Fujitsu annealer. Can only say ours is twice as fast. It's a small machine you can put on a desk. So we're working on new algorithms that are aware of the context in which they are executing, all the way up to integer-oriented machine learning algorithms that we are working on, and of course classical ways of looking at the performance of machine learning algorithms. If we go to the right end of the spectrum, the context is reflected in the research areas human-centered systems and embodied AI. Human-centered systems, and I had just a very, very interesting discussion with Isabel, where are you, about that you need to do experiments with humans, and that's precisely what we're doing here. We exploit human interaction, we're learning from data. This is the research area of visual analytics, of AI-driven visual analytics that we're working on here. And on the right-hand side, embodied AI is just what you would think it is. Right now it is robot, but it's also sensory and actuary systems. Our colleagues in the center, in the Lamar Institute, have won several robot World Cup championships in service robotics, also in soccer robotics. So this is the area of embodied AI. The final area is not the least, because that's basically at the bottom of everything we do, or at the heart is trustworthy AI. So we have a very, very strong investment in algorithms that help humans understand AI and help make AI understandable and trustworthy. We also have a number of application areas. Excuse me, where do I want to go? Maybe here? Okay, there we go. Application areas, I'm not going to explain these, but just to emphasize, for us, these are not just applications where we talk to domain experts, but we have research colleagues in there in an interdisciplinary fashion. You see that here, and all of these guys are very, very respected authorities in the respective areas. So when we do applications and when we do interdisciplinary research, we do it with the right people, and we're very happy that all of these have joined us. All this work, of course, has translated into a multitude of publications. You've seen many of these, so maybe let me not repeat that here, but let me give you an insight in what we do in applications and transfer. Let me mention just a few things that we've been realizing that we're very, very proud of. So we are running 24 hours a day, 7 days per week, one of the largest AI applications in Europe and probably the world at Germany's, or I think Europe's largest broadcaster, WDR. This is the platform that is processing with our AI 100,000 media assets 100,000 media assets daily. That's 130 TV and radio stations being analyzed with AI as we sit here, as I stand here. We have done retail planning for large car manufacturers. We have optimized optimization for a steel plant. And we've also been doing very mundane things like automatically reading company reports. So one of the largest German tax advisory companies, or actually the fourth largest of the world, is having 250 installations where tax advisors have AI read company documents. Very, very challenging things. One of the most recent things is we've won one of the biggest German car manufacturers for a 2-year trial project to test our language speech solutions in their cars. So hopefully you will be able to buy cars with Lamar Institute speech stuff in them very, very soon. As I said, beyond all these applications is that we believe in triangle AI, we can do all this quality of work. All of these are really best-of-breed systems that we have in practice, but make at the same time everything trustworthy. So we have an explicit, at the Institute, an explicit ethics statements and ethics guidelines that we work on. I'm not going to go into the details here. There's plenty of papers of that. You see the Bond catalog here. This is what we adhere to. That's what we want to do in our work. But we don't just do that for ourselves. We actually also, in trustworthiness, work in lots of regulatory bodies in Germany. So personally, I have the pleasure of being in the National Platform and Steering Committee on Trustworthy and Certified AI, and you can see many of the other things that we do here. So everybody who doesn't know about this yet, I'm inviting you to perhaps read up on this and maybe get back in touch with us, because next to all the fundamental algorithmic things, trustworthy AI is very close to our hearts. And I think my 10 minutes are over now. Thank you. Thank you.
Thank you very much. Now there will be the presentation of the Dfki by Philippe Slusalek.
Yes, hello. Is this working? Oh, then I don't need this one. Welcome. Yes, my name is Philippe Slusalek. Hopefully we'll have the slides up in a second. I'll be giving you a quick overview of the Dfki, the German Research Center for Artificial Intelligence. I'm a professor at Saarland University, and I'm heading the Saarbrücken side of Dfki. You'll see an overview of the different sides of Dfki in a second. Yes, we have the slide. So the mission of the Dfki is to empower German society and industry with AI know-how and technology, promote the innovation. And specifically, we're very applied research institute, so we work very closely with industry to transfer the knowledge to that, provide new startups, but also we are deeply involved in developing the German AI roadmap through various groups that we're involved in, but also at the European level. So I'm one of the co-founders of CLAIR, for example, so we're deeply involved there together with Indriya. We're also working on the basic research side to extend the AI knowledge that we provide, but this is a key part of then being able to transfer things to industry, but really also promote AI made in Germany and in Europe on the global scale. This is a key element. And so in that sense, the Dfki really builds a bridge from fundamental research that we all do into really making it possible for industry and society to pick that up. So as I said, we are focused here in the center on applied research and then transferring that to industry. I'll have a separate slide on that. However, Dfki is not itself really involved in the exploitation of those results, but we provide technology, prototypes, templates, and lots of other things to our commercial partners. You'll see them in a second. Also, of course, we enable and provide that technology to our startups and many external clients that we're working with. However, as you know, AI moves forward very quickly. And so for a lot of the stuff that we want to do applied research and transfer, the basics are actually missing. And so we do what we call application-oriented basic research in Dfki. But all of our directors also are professors at the local university. And so we are deeply rooted in the local ecosystems at our sites. And we take that basic research. We do it ourselves at our university groups, and we work with others at the different sites. Dfki is also very different in the setup. We are a GmbH under German law, so we're actually a private company focused on research. You see here the Dfki shareholders. You certainly recognize many of the top names from international companies like Google or Intel, NVIDIA, and many others, SAP, Software AG, and many other German big companies, Bosch, the automotive industry, BMW, Volkswagen, and so on, you name them. They are shareholders. They're not necessarily, they are co-financing us, but it's different to the French Institute, which is mainly funded through those organizations. This is different here. They're shareholders, but they fund us only to a certain degree. The sites that we have covered in Germany here is a large part of Germany. Originally, Dfki was founded in Saarbrücken and Kaiserslautern. Saarbrücken actually right on the French border, so we have very close connections that I'll talk about in a minute. We added in 2006 Bremen, Berlin. Now, actually, as of 1st of July, we'll have 2 new sites in Oldenburg, full sites in Oldenburg, Osnabrück. We added a few smaller sites, and the latest addition, and you're one of the first to hear that, is that just 2 weeks ago, the Darmstadt, the new lab in Darmstadt was approved officially. So you know the Jan Peters, Carsten Binnig, and Kerstings. are the key researchers on that side, joining the DFKI ecosystem as of now. They are not listed here in this picture yet, but they will be 49 professors across all areas, so we cover almost every topic in AI. And as I said, each group runs a largely independent research area, including a university group, so we're really tightly integrated into the local ecosystems at all the sites that you just saw. But we're also a very international company or organization. Actually, our employee numbers is probably across 1,400 now. Most of them really scientists working on the different projects. I'll have some numbers later. Staying typically up to 5 years. Of course, in many other cases, we saw this also earlier, we need to work heavily on our female staffing. But the point here is DFKI, right, in the last 7 years, 2,000 of our employees went to industry and to other organizations, so there's really a strong pipeline of turning out AI expertise through DFKI. DFKI has been growing very, very quickly, about 15 to 20% during the last whatever number of years. That's all I wanted to say with this slide here. And beyond the individual research groups that I listed here, and I can't really go into all of the research that these groups are doing, we have cross-cutting what we call competence centers in different areas such as autonomous driving, where different groups contribute their specific knowledge and we combine that to make offerings to the industry. We have one for deep learning, which is more method-oriented, and you see the list of other topics. And on the other, these are more research-oriented competence centers, and we have living labs where we really have large-scale demonstration centers that we're running together with industry to really show off what AI can do in certain areas. Particularly the smart factory in Kaiserslautern, for example, is the main site for showing what AI can do in manufacturing. As you might know, DFKI founded the term Industry 4.0 with a lot of AI, of course, part of that. We have something I think that's really interesting as a new way of organizing research with industry, right? In the past, it was like we did our research, and at the end when we had our results, then industry became interested and then took over, and then they did whatever they're doing. So what we're seeing in the last few years, and we've established this as a program, as a key program at DFKI, is to really front load that research collaboration. So industry now gets involved in our research much, much earlier. And these transfer labs are really about bringing the industry people into the DFKI ecosystem. And we have now close to a dozen of these transfer labs where we work very closely. And the funny thing is, part of that is industry is actually funding basic research in those areas as well. There's lots of research achievement. I don't want to go through all of that, huge numbers of publications. Of course, because we do transfer, a lot of the publications are not necessarily in the core AI conferences because, right, they go into the different industry publications that we work with. But I already pointed out the large numbers of PhDs that we are producing, if you want. But also 44 of our professors, of our employees became professors in German and European and international events. Really, the core of what we're doing is industry projects, close to 400 industrial partners internationally, over 1,000 partners, industry partners, only in the last 7 years. On the German side, large numbers of projects here of funding that we get from industry for doing this work, and lots of spin-offs that come out of that collaboration with industry. Just to close off, besides the research and the transfer work that we're doing at DFKI, we are really heavily involved also on the more strategic and collaborative efforts from the local collaboration at each of our sites. In the regional collaboration, for example, Emmanuel Vincent from Indriya Nancy and myself are collaborating our joint research between Indriya and DFKI. We started that collaboration with a big collaboration effort event in beginning of 2020. So it's really a national German-French collaboration between Indriya and Dfki. We're instrumental in setting up 3 of the 4 networks of excellence. We help run the vision coordination action, and we're also supporting the commission in international AI activities. I think this is probably and this is my last slide here, is the strategic collaboration between Indriya and Dfki. We have committed up to now 6 million roughly from our funding dedicated 4 projects that we do together with Indriya. You see some of the topics and the names here. The most recent one is engaged in the area of AI and high performance, bringing AI and high performance computing together. We have weekly coordination meetings, myself in particular with Mcml. We have regular meetings at the CEO levels. We run 2 summer schools every year now, and we have at least weekly workshops. So there's a very close collaboration, and that extends to also bringing that combined knowledge and that ideas about how AI should go forward also into these European initiatives that are listed here, at least partially. There's one more slide. One of the things that we're currently pushing on the German side is what we call trusted AI, which actually has a nice counterpart in the Confiance.ai initiatives on the French side. And we're in contact now to link those 2 initiatives together. I think this trusted AI, this ability to provide guarantees about the functionality of AI systems, not only of the AI system itself, but in the wider system context, is really a core part of what we need to do in the coming years. And we want to provide our contribution for that. Thank you very much.
Thank you. Now we will have a presentation of Daniel Kremers for MCML.
Thank you. All right, so I can see the slides, you can't see them yet. I hope they're coming up. This is the presentation of the Munich Center for Machine Learning. My name is Daniel Kremers. I'm a chair of Computer Vision and Artificial Intelligence at the Technical University of Munich. It's a pleasure to be here and to introduce MCML to you. MCML, the aim of MCML is to really bring together machine learning experts from the entire Munich area. And so it builds up on competence both from Technical University of Munich and from the LMU. Both of them are among the top-ranked universities in Germany. And it's, I think, one of the biggest machine learning competence centers in Germany. We brought together about 50 professors from both places. So invariably, it's a little bit difficult to give you a complete overview of all the things that are happening within MCML. You've seen this landscape of German competence centers, and down here in the bottom right in Munich is the MCML. MCML is headed by 4 directors, 2 from LMU, 2 from TU Munich. This is Bernd, Laura, Thomas, and myself, who are the board of directors. In addition, we have a strategy board that includes people, again, from both universities, Massimo, Stefan, Eike, Gitta, Daniel, Albrecht, Hinrich, and Fabian. So it brings together a lot of, I think, some people that we feel are some of the key machine learning experts in the greater Munich area. And as I said, there's 50 PIs, so I'm not going to show you all their pictures and names because that would be a bit overwhelming. But there's a lot of support, and so we do a lot of activities. We, have speaker series. We do a lot of workshops. One of the workshops, so maybe rather than going into all the things we do, I want to give you an overview of the research areas that we have within MCML. There are really 3 areas. One is the foundations of machine learning. That includes a lot of mathematical and statistical foundations and algorithmic foundations of machine learning. Then there's the second area that is perception, vision, and natural language processing. And the third one is what we call domain-specific machine learning. So give you a closer glimpse here. I think the slides are not updated. I sent an update, sorry, somehow this wasn't included. This is an older version of the slides. Sorry about that. So the area A is foundations of machine learning. There's the statistical foundations and explainability. Then mathematical foundations and computational foundations. And there we really draw on the large departments of both computer science and mathematics that we have at both of these universities. So that really has a strong foundational component that I think is very important for machine learning. Here's an example from this foundations area. Again, this is just one example out of a lot of research activities. This is from Massimo Fornasier's team in the math department. And what you see here is numerical simulations of people trying to find an exit in a building like this one, for example, if there was a fire. And what you can compare is simulations where all the individuals are kind of moving around unconstrained. And below you see what's called control dynamics, where you have a few people that are kind of informed and that kind of, with their motion, help influence and guide the rest of the crowd, much like shepherd dogs do when herding sheep. And it turns out that actually works, and they didn't only do numerical simulations, but also really experiments to see, can we, with a few informed agents, help to control a mass of people in such events. So this is just an example from the foundations area. This is the area B, vision, natural language processing, and what we call multimodal perception. So there again, there's a lot of researchers behind this. I can't really go into all the aspects, but here's one glimpse of research of a very recent work that we did at this year's ICRA robotics conference. This is a system we developed. I hope the video is gonna, no, it doesn't. The videos don't play. Oh, that's a bummer. Sorry, I should have checked the presentation. I didn't know that the videos were not playing here. Is there a back button as well?
Yes, one of the black button.
One of the black buttons. Is this?
One.
Oh.
It's okay?
Yes, except the video still doesn't play. Oh, that's really a bummer. Sorry. We should have tried the slides beforehand. I wasn't given the chance to try them. Next time I'll use my own laptop. So never mind then. So I'll move on. The third pillar is domain-specific machine learning. And here we identified a number of what we believe societally relevant application areas of machine learning, including medicine. There's a lot of medicine research in Munich with the two big hospitals behind it. And this is focused on personalized medicine, in particular topics like that, how to improve diagnostics and treatment with machine learning techniques that tap into all the data that we can acquire these days from different modalities and try to improve treatment and diagnosis. Then there's biology, proteomics research, things like that. Then there's physics and geoscience. And then there's also computational social sciences, a field I think that requires a lot of machine learning to process all the social science data that we have these days from Twitter or else, to understand how humanity behaves, how they evolve, etc. And humane AI, that includes topics like ethics, for example. This is an example from Xiaoxiang Zhu's lab on Earth observation. I hope that video plays. Oh, that one plays. So it's just my videos that they don't like. So this is Earth observation, where we can tap into satellite imagery, synthetic aperture radar to really recover very large-scale, high-resolution details models of the world. And we're in collaborations on how to expand this, how to use deep neural networks, for example, to tap into images, to understand. You can use, for example, this is work from Xiaoxiang's team, where they tapped into street view imagery to try to classify aerial images in terms of what kinds of buildings are we looking at. Apartment buildings, churches, garages, etc., etc. And I think there is a lot of need to really process the human development, for example, or developments like deforestation with machine learning algorithms. And we recently published together with Xiaoxiang's team a paper called that we call Dynamic EarthNet, that's going to be presented next week at CVPR, that really has a very detailed, also highly time-resolved understanding of the world's development. So there's a lot of machine learning needed for this field of Earth observation. So this is just a few glimpses into these three pillars of research that make up the Munich Center for Machine Learning. And in addition, as I said, there was one more slide that I added, but it wasn't included in here. It's about our collaboration with France. I think this is very important, and it's something that is personally very dear to me. I've lived in France, I speak French, I really love France, if I may say so. And so, as you may remember, last year, together with Jean Ponce's team from PRAIRIE, we organized the French-German Machine Learning Symposium, and I do hope to engage similarly in the future to strengthen this collaboration within Europe. Thank you.
Okay, thank you. Before moving to the next speaker, if the people sit on the stairs want to take a chair, it's possible between the change of speaker. As you want, up to you. Now the presentation will be given by Wolfgang Nagel.
Yes.
For SCAI AI.
SCAI AI, you're right. Thank you very much. Welcome. I'd love to present SCAI AI with the Center for Scalable Data Analytics and Artificial Intelligence. And now I have to find out how this will work.
The white button.
The white button. Wonderful. Worked for the first time. Some words about history. We started in 2014 already as one of the two German-wide operating big data centers. So it is an investment for years which the ministry has put into us, and we are trying hard to keep that and bring it along to the AI field. So it's a shared operational center between Leipzig and Dresden. We are coming in the Saxony, which is one of the eastern part of Germany. And we had, at the former time, 4 additional funded application partners, actually from Max Planck Institute and Leibniz and so on. In end of 2019, we got additionally the duty and the opportunity to work further and deeper into the AI field. So what we are doing is we keep the domain scientists. We have a strong service center, and we want to bring skills and expertise to the communities. And with that, the SCAI AI highlights of the new center, which will be founded, I think, in 1 week or 2 weeks or so. We want to work on AI algorithms and methods. We want also to put big data analytics and engineering into the boat, and we want to focus on big data and AI applications. And I will show you in a minute how we will organize that. There is an extended research on responsible AI and ethics, and you will see that also, which is interdisciplinary, and we have also colleagues from this part which are joining us today. And what we can bring in as additional funding is the National High Performance Computing Infrastructure from NHR, which also Dfki is working on, but also other infrastructure providers in Germany. And we are one of the 9 providers which are specially focused on supporting the AI communities. We have also new AI hardware development. I will talk about Spinnaker in a minute. And yes, as pretty much everybody, we are looking for new professorships. If there's somebody, please let me know. We have extended our cooperation partners from 4 to 10. So at the end, 10 cooperation partners will help us from the non-university research labs. And also we got very strong federal state support already in the last 2 years, which helped us a lot. So overall, you can see the three mentioned areas, AI and big data, algorithms and methods, and also data analytics and engineering. And you see the interdisciplinary activities in the responsible AI field and also on architecture, scalability, and security, which is an important point. What you can see is that we also are looking for junior research groups and will support them. We have quite a number of opportunities for principal investigators. And last but not least, the Service and Transfer Center will have definitely outreach to many areas all over Germany. And education in the graduate school is also a very important point. If you look to the fields, and I will not describe all of them, the big data analytics and engineering is on open data and open models because we need data. We know that for 8 years of big data competence center. There's data quality is a big issue. We have seen slides this morning that 50 to 80% of the data handling has to be done before 20% is coming with machine learning. So you have to bring things together. And there's also the big data analytics on that level. There are quite a number of original AI new fields which we are doing in the area of efficient learning, for example, but also on the mass foundations and statistical learning, where we believe that there's a strong need for doing several steps. And also we are driven by the field of the applications. You see life sciences, medicine, but also environmental and earth sciences, which is very strong also, not only in Dresden, but also all over the place in Leipzig and in many other areas. Bringing things together, the research highlights are excellent research on the whole data science spectrum, including big data and also large-scale data management, data quality. There are the AI and machine learning methods, and yes, we are driven by challenging application areas. There's a strong AI research, especially also in the knowledge management. I mentioned already mathematical and statistical foundations. What might be interesting, and I will come to that also in a minute, is the new inspired computing for real-time AI, and we have developments ongoing with that. And last but not least, I mentioned also the responsible AI, which will drive a holistic approach. One interesting feature I want to mention here is understanding language. Many are doing that all over the place, and the research covers domain-specific language, modeling, text manipulation algorithms, argumentation, and also causal language. What you can see is that there was a big success with GPT-3. And you know, GPT-3 is not really freely available. And there is I think, great opportunity with OpenGPT-X, which hopefully will drive us in an area of open availability of models like that. And we hope to get close or even beyond what GPT-3 is providing, but having that in an open fashion. To bring things together these days, most of the AI people know that we need also HPC. We have worked on neural networks for a long time, but with the GPUs, it has made a significant step forward. We have in SCAT's AI computing capacities for tier 2 performance class, which means that at the end there are roughly 15 to 20 petaflops available for the community. We are generating knowledge from data. We are working on specialized HPC architectures on the workflows, and also there's a large-scale big data and machine learning applications which you can use there. And you get consulting on AI methods. There are complex machine learning models. And last but not least, there is an extensive big data pipeline which we can support, especially because we have a very fast data storage infrastructure. And you always have to bring things together, bringing data, HPC, and AI methods on the highest level, and then generate solutions. What is special is we are close to the fabs which are generating chips in Europe. And Spinnaker 2 is one of the developments. It is, for our knowledge, the largest real-time AI and brain simulation platform worldwide. It is coming to life within the next 6 months, roughly. We will have in the order of 10 million cores, which can be used in a very efficient way, which allows to have completely different models running very efficiently. It is additional funding from our local state, and it allows us to have a second opportunity besides the NVIDIA, the usual way, and some other activities which are running on our side. The last slide says, if we have success, it is not only success for AI, it is also success for extreme scale research. And we want to help to make that productive. So whatever you need, HPC, AI, data, across all disciplines, in all science areas, this is what we are intending to support. With roughly 60 PIs, as we have seen a couple of numbers, this is pretty much the same order in most of the centers. So we have made our transformation steps from HPC and AI to data analytics, and also to digital sovereignty. We want to have hardware which is designed in Europe and which is run in Europe, and which allows us to be independent from what other people might provide. We want to support users for their daily work in their software environments, and this in all disciplines, not only specialized on special areas. HPC scalability is an issue, so going beyond 8 is an important step, and then there will be 16. We have 272, which you can use these days, and this allows us up to the 10 million at the end to go with other opportunities of scalability. We have standards for the interoperability of data processing steps, and we want to have the full data lifecycle available on our site, from the acquisition to long-term storage, also for the National Research Data Infrastructure, NFDE. There are joint developments with all colleagues you see here in the room, and also the collaboration. We want to make data analytics and AI services available based on HPC, which we can support. At the end, the goal is data analytics and AI on an extreme scale. It might not be exascale, but it easily can be 10,000 to 100,000 times faster than today. It will take a while before we have a press on a button. But nevertheless, this is what we are working for, and this might be for the whole room. Thank you very much.
Thank you very much. I think the next presentations are remote by video conference. Do we have Matthias Bettger on video conference?
Hello, can you hear me?
Yes, we can hear you, but we cannot. Yes, we can see you now.
Okay, great. Thanks for giving me the opportunity to join virtually. Unfortunately, I was hit by an evil virus, which knocked me out for several weeks. So I'm happy to join at least virtually now. Also, my presentation might be a bit more high level than the previous presentations because I didn't have so much time to go into to add new stuff. So I start with the big picture. Since the beginning of the Industrial Revolution, there's been a sequence of major transformations, each of which massively changed our economic world. All these changes have been driven by enabling science and technologies, and the beginning of the Industrial Revolution was the rapid growing understanding of how to transform and store energy, now known as thermodynamics. Today, our industries rely on massive information processing, but most of it is still based on computers that have been programmed to follow exactly preconceived decision rules. Machine learning changes the way how we instruct computers. Instead of programming decision rules, we now instruct them with learning rules and data. This is a game changer since now machines can also learn things that go beyond what we already know, such as the prediction of protein folding. However, in spite of all successes with superhuman performance on individual tasks, we are still only at the beginning. Comparing learning machines and brains shows that there's large room for improvement for machine learning to become much more powerful in terms of generalization, robustness, and data efficiency. So there's an endless number of popular demonstrations how generalization can strikingly fail in current machine learning. For example, an area where progress has been impressive is object recognition, where we train systems on huge sets of labeled images, and by some measures of success, we achieve human level or even superhuman performance on these sets. However, if there are things in the test image, such as a beach or the sea, that are negatively correlated with the presence of an object, like a cow in the training set, recognition fails. So the reason is that the standard paradigm of machine learning only looks for correlations. It does not care about causality. And since current learning systems are so highly optimized to a given distribution, they are not robust with respect to even small interventions. If we add a little bit of malicious noise to a test image, imperceptible to a human, a system may suddenly classify a little pig as an airliner. In conclusion, machine learning excels at IID pattern recognition, and we have become good at turning problems into IID pattern recognition problems. However, to make machine learning work in the world, we need conceptual advances rather than just more data. And conceptual advances also need top talent. So our pitch for the Tübingen AI Center is that we see an opportunity for transformative breakthroughs in AI on making machine learning work in the world by advancing the foundations of causal and robust machine learning, and by constructing and establishing more mature, usable, and societally beneficial and acceptable technologies. To this end, we focus strongly on attracting top talent and covering the full stack of machine learning from the foundations to methods, systems, and societal impact. And on supporting broad impact such as technology transfer, outreach, and education. The Tübingen AI Center is run by a careful selection of researchers from Max Planck and the University of Tübingen that have been internationally vetted to meet the excellence bar of being Alice Fellows. This diagram shows our hiring history of the existing tenured faculty in the center. We have been recruiting top researchers within the last 4 years, 8 full professors, and 5 of which were internationally hires, also some against competing offers from Berkeley. So for the next 5 years, our goal is to hire 8 more full professors and 50 new W2 Max Planck independent group leaders. And of course, we would be highly delighted if many of your students and postdocs are going to apply. Legally, the AI Center becomes a joint department between the University of Tübingen and the MPI for Intelligent Systems, with far-reaching rights to govern all academic matters in coordination with the Deanery of the Faculty of Science. So our core faculty will be in power of all strategic decisions in the future, such as hiring the new faculty. In addition, we have taken great care to create optimal synergies with the surrounding ecosystems at the regional, national, and European level. We believe that Europe needs to develop a strategy that focuses on excellence in AI, which is why we are strongly engaged in the ALICE initiative. And we also received a private endowment from one of the SAP founders to build an ALICE Institute, and the goal is to create internationally competitive positions for outstanding researchers by offering co-appointments in this institute. We also developed a joint strategy with the regional Cyber Valley initiative to further improve our support for technology transfer. Most importantly, the AI Center provides a pre-seed fund with which we can try out and test ideas for applications in a lean and agile fashion. And complementary to the core faculty of the AI Center, which has strong expertise in core machine learning, the Excellence Cluster in Tübingen focuses on the interdisciplinary use of machine learning to advance the sciences such as neuroscience, geoscience, physics, social sciences, and so on. And the Excellence Cluster is funded by the German Excellence Initiative with 35 million euro. Of course, education also is a crucial goal of the AI Center. Currently, we educate more than 200 PhD students, and we expect this number to grow above 300 within the next 2 years. And this brings me also to a great opportunity how we can foster Franco-German collaborations in the LS PhD program. Each LS PhD student always has 2 supervisors from different countries, and they have to spend at least 6 months at either location. So for the students of the program, it's highly attractive, and is because also they can apply with a single application to a huge number of top labs across entire Europe. So even the faculty of Stanford or Berkeley do not match the impact of 380 LS fellows that the LS network has. Of course, our education is not limited to PhD students. We have dedicated education and outreach programs starting as early as teaching programming in all elementary schools in Tübingen, various offers for high school students such as the National High School Competition in AI and a newly established makerspace. At the undergraduate level, we have Germany's first master program for machine learning. And for postgraduates, we offer a free-floating postdoc program and, of course, the very attractive W2 Max Planck research groups that I already mentioned before. So our ecosystem has also attracted multinational technology companies to Tübingen. For example, Bosch and Amazon are constructing large-scale research centers that are planned to host up to 900 employees. And through the Industry on Campus program, other corporates like Zeiss, Festo, Schufa, and Neva have established research labs at the University of Tübingen. And this growth also requires more space. So we are extremely happy that we managed to bring the entire faculty of the AI Center on one campus with a maximum extension of 800 meters, which means everything can be reached in less than 10 minutes walking distance. So that was my bird's eye perspective on the AI Center. I hope you got an impression what we are doing. In terms of research, of course, I think the foundational research in AI with its application in computer vision and other areas is pretty similar to what you are doing as well. And so I think there are lots of possible synergies for collaborations. Thanks so much for your attention.
Thank you very much. Thank you very much for this presentation. Now we have a last speaker, Klaus Mueller. Can you hear us?
Yes, I can. Can you hear me?
Yes, perfect. So I think you can share your slide.
So you're not sharing them?
No.
That's interesting.
Yeah. It's better to leave you the control.
Okay. Yeah. Okay. Do you see anything?
Yes.
Okay. try something. Okay. Can you see?
Yes, we can see them in full screen. That's perfect.
Wonderful. So, yeah, thank you very much for giving me the opportunity to talk and to talk about our Berlin Institute, the Foundations of Learning and Data. I'm Klaus Miller, and I run this center together with Volker Marke. I would have liked to come to Versailles, and we do actually have French genes. A great-grandmother from Paris, and so I love France, but I also only recovered from Corona about a week ago, so I think it's not wise to travel. So hoping that you have a good time, I will just briefly introduce the center and its history. So we started out with the Berlin Big Data Center in 2014. It was run by Volker, and I was chef, which was focusing on also research on database management systems, and in particular the machine learning that needs to be. In 2018, we started the second center in Berlin, which is the Berlin Center for Machine Learning. We put more focus on the theoretical side and also the interdisciplinary research side in the sciences discipline. But also, again, towards the foundational aspect of the database management side. Then our government, in its wisdom, has decided that because you know, the machine learning center was run by me and by Volker as my sous chef, we could both be you know, directors for a new institute where this big data and machine learning center put together. And so you can see that it's now called Bifold. And it has two main parts: machine learning and big data management, which I think is a essential part for doing AI, because you need to not only think about new algorithms and new theory for machine learning, but we also need to think about what to do when data becomes a lot. Also, there's an issue that both fields, database management and machine learning, they have been running, so to say, full steam against a concrete wall, each of the fields in its own way. So machine learning, because it has been mainly ignoring aspects of the data management side, and big data, because it has been mainly ignoring that some things are iterative and the queries need to be asked in a more complex way. So, you know, we have now the best of both worlds, where we educate students in both disciplines, be literate in both disciplines. So this is like the Berlin area. Berlin is very rich for doing research. It has lots of Max Planck Fraunhofer Institute and several universities. And so Bifold encompasses many of these, and TU Berlin coordinates. So we have established already a number of research groups, and but as you know, on 1st of July, the centers are going into a different phase where we need to grow and scale, and so you see the people that we have now, or the groups that we have now, but we are about having something like 10 to 12 professors in addition. So the mission statement that we have is basically to do foundational research in big data management and machine learning and its intersection. So I think that's quite unique for our Berlin Center. And so very importantly, not only you know, staying with our disciplines, but also doing transfer to the sciences and humanities, creating new startups, transfer, educating scientists. Matthias has been, elaborating along these lines for it. I won't repeat that. But I think it's boring to talk about all the structures, and if there's no science. Also, the idea, I think, is that meeting is also about getting to know each other and getting to know research. In Berlin, we've been doing a lot of explainable AI in the last more than a decade. The idea being that, usually you train your neural net, your recurrent net, your kernel machine, whatever, and make a prediction. But if you would like to do something more serious in the sciences or in industry, then there always comes the question, what does the model do? And is it safe? Can you understand what it does? And explanation is basically the discipline that has created itself for the last decade to answer these questions. So if you think about here, this innocent neural network that allows to classify images, and here this is the rooster, so the neural network says it's a rooster. Then the question is, can you put this neural network upside down and try to explain in terms of the input pixels what the neural network does and why does it think that this is a rooster? And you can see there's a heat map that comes out of this. Green is neutral, red speaks for the decision making. So you can see that this particular neural network that was downloaded from somewhere, I think Alex in this particular example, the rooster is classified by its code. So all the black box, criticism to neural networks, because there's now a theory how to put the neural network upside down, is not valid any longer. So, and our algorithm is called layer-wise relevance propagation, but there has been a slew of other. Second aspect, trying to do machine learning for the sciences. Some of you know that I have been adopting a quantum chemistry hobby, so where I try to understand the quantum properties of materials and molecules. And so for this, you actually have to solve the Schrödinger equation, which is only possible in closed form for the hydrogen atom, which is not so interesting. But approximations exist, and they're called, for example, DFT, which stands for density functional theory, and got some Nobel Prize. So the computation is excruciating. So it takes many hours to compute the property of one molecule or month for materials, and DFT is already a cheap approximation to solve the equation. So there's also other ones like CCSD, parenthesis T, where you take days for one molecule, computing mechanical properties of one molecule. So if you see the picture, it's like a bit of a starry night. That it alludes to the fact that back in the days people have been trying to make to chart space in order to navigate, for example, and to understand how the universe fits together. And so there's no such chart of chemical compound space. And if we had one, it would be very wonderful because we could maneuver in this space and look at properties and everything. And so with hours or days of computing, this is totally impossible. And with machine learning, which shortcuts the idea of which learns how to approximate the Schrödinger equation, this is actually becoming realizable. So the idea being, and that was something that we proposed 10 years ago, the idea would be to get some data from these quantum chemical calculations and use a machine learning model to predict the outcome of the Schrödinger, and in this way be blazing fast. Okay, so now if we do this, we may use a neural network, as you see, and we may predict some prediction of molecule. But the question is, can we learn something new? Because we have now explanations in science. Can we learn new chemical properties? Can we learn chemistry that we don't know before? And you know, this 2017 paper was really the first which showed that this can be done, that we can actually not only learn from data, but we can also then analyze a model, a machine learning model, and gain insight from it that we didn't have before. So with that, I would like to, these are interesting times, and I think it's a whole new possibility for us to do this, you know, to gain insight in the sciences, assisted by machine learning models. So I thank you very much for your attention. And, yeah.
Thank you very much, Klaus, for this presentation. We have now finished the session for the presentation of a German research institute on AI. Many thanks to all the speakers who have respected also the times. And for the following, Stéphane Canu will give you the program.
Okay, I'll go back here. Okay. Coffee break next. And after a parallel session. And after a release of everybody, so before to releasing you, I'd like to thank you all for coming. I'd like to thank the organizer for this very nice workshop, in particular Frédéric Vidal, who works a lot for having us here in very nice conditions. I want to say two things. Now we have parallel sessions in different rooms. You have seen there is stickers, so in Amphi Lyons, we have computer vision. In Salle Renoir, NLP and Giga models. En featuring trustworthy and explainable AI. In room 006, resource-aware AI. In Pissarro, Salle Foundation of Machine Learning. In Salle Monet, I read machine learning, knowledge and data. So you can go there. But last but not least, I want to make some advertisement. Next, ECML will be in Grenoble, so feel free to come and visit us if you like France, to come to ECML Grenoble in September. Okay, thanks again. Then coffee break and parallel session.